Good morning, everyone. It seems that you all more or less speak English, so I will speak in English. So I'm a climatologist, and most of the climatologists now really want to go towards what we call climate services, that I will talk about at the end of my talk. And climate services mean put our knowledge in the hands of those who need it. And here the objective is to see what kind of knowledge from climate you want to have and how we can work with you. So what I will do is first I will show you that our climate is changing, although you know about it, maybe you don't know everything. So we'll go back, we'll go through the unchallenged reality, the role of human actions, and what happens at the scale of our countries. I will briefly show you that we shall not mix up climate variability and climate change, and that's at least in the society every day. When in the middle of the summer you have suddenly a cold week, everybody says, oh, climate warming is not happening. That's climate variability, it's not climate change. We are going to look at what has already happened in the farming sector. What are the futures of our climate? Futures with an S, because there are potentially several trajectories, and how you and us can work together. At least that's what I'm here. I'm here to try to see what I can do with you. Okay, so this curve is showing you since 1850 on the x-axis up to today, the time evolution of climate temperature at the global scale, so the mean global annual climate temperature, as a difference between a reference period, which is between 1850 and 1900. Okay, so it's anomalies, it's differences, and what you see from all the curves is that we are, of course, raising continuously since the end of the 20th century. So climate is warming, and we have today reached 1 degree Celsius since the end of the 19th century. Okay, so we have already reached 1 degree Celsius, and you've heard about the latest report from IPCC that says that the governments want to stop at 1.5 or 2 degrees Celsius. And yes, it is indeed feasible. But if it is feasible, if by 2030 we cut our emissions by 50% compared to the 2010 level of CO2 emissions, and it is possible if by 2050 our mean emissions of CO2 is zero. So we capture as much as we emit. In those conditions, we can stop our warming at 1.5 degrees C. Okay? So what you see here, and that is also interesting, is that since about the year 2000, we are experiencing warm weather that have never been experienced over the past 10,000 years. Okay, the 10,000 years limit is the pink shading here. So that's something that you need to know. Okay, so we are warming today at 0.2 degrees C per decade. So that means that in 25 years from now, we will be at 1.5 degrees C. What is interesting here, this map is showing you, and I thought it may be interesting for people who are farming the land, it's the season of the greatest warming. And what you see is the season of the greatest warming is really different from one country to another one. So if you look, we have Australian people, so if you look at Australia, it's March, April, May. That has been the season of the greatest warming since the end of the 19th century. You see that in Europe, we have a very strong gradient. In the Mediterranean Sea, we have June, July, August, so it's really the summer that remains the warmest period, but also the period that has undergone the strongest warming. In the more temperate latitudes of Europe, it's the winter. We've been experiencing very warm winters over the past century. And that's the season that warms the largest. And in the very far north of Europe, it's the spring. And I think this also is important because the level of warming being different, it means different things for the crops that you are growing. So when we say that it's an unchallenged reality, we do not only rely on temperature. That's the thing that you hear the most in the newspapers, that the air temperature is warming. But we have a number of evidences. And if, as physicists, we just think of what would be the several manifestations of a warmer climate, and if we, after that, look at the realizations, we see that all the manifestations are there, and they are summarized in this picture. So, for example, if you take the glacier volume, it's shrinking, so it's diminishing. All the glaciers in the world are really shrinking. If you take snow cover also as mean annual is shrinking, and it's melting quite earlier, which has some problem for the hydroelectricity, for irrigation also, because water will not come at the same time in the future. Of course, the temperature over land, the temperature over the air, the water vapor content, that is something that is very important. The water vapor content of the atmosphere increases. The warmest is the air, the more water vapor you can put in the air. And the consequence of that I will show later, is the intensity of rainfall. Because the atmosphere, a warmer atmosphere, can contain more water vapor, it means that when it's raining, there is more water to go into the rain. And that is why intense precipitation events are more intense today than they were a century ago, and they will be more intense in the future if we keep warming our climate. The sea area, of course, is shrinking also, and a very important thing is the oceanic heat content. The first 700 meters of the ocean is storing 90% of the energy we are putting in addition to our climate, 90%. And it's restoring it. It means that even if we were to cut all our emissions today, the ocean will keep restoring this energy that it has stored for many centuries. So we will keep warming our planet because there is a memory of what we have done, and this memory is in the ocean. Okay, so all those evidence are put together, and that is why we know that climate is changing, because all those evidence go into the same direction. There are other evidence that are, I guess, really problematic, especially for you, because if you had a smooth warming, why not? I mean, you have time to adapt. 1 degree, what does it mean, 1 degree? And I used to tell my students is that 5 degrees Celsius colder is the last glacial maximum on Earth. 5 degrees Celsius colder, it's 120 meters sea level below the sea level today. In the Mediterranean, I don't know the ones who have heard about the cave Cosquer, that is now today 70 meters below sea level, that scuba divers discovered a few decades ago with paintings in it. This cave was above sea level. In the Mediterranean, you had seals, you had penguins, and you had a 3-kilometer ice sheet over the Canada, over England, over Scandinavia. That is just 5 degrees colder. So 5 degrees colder is a world that we don't know about. And if we reach 5 degrees warmer at the end of the 21st century, it's also a world that we don't know. So it's the mean value is not a big deal. It's really its manifestations that are important. What we know also is that there are a number of extremes that we know can be related to climate change and that have already occurred. So you have heavy precipitation events, as I just said earlier. And this is because the atmosphere contains more water vapor. So it condensed later and with much more water. Droughts in the Mediterranean area and in West Africa have increased. Droughts in Central North America and Northwest of Australia have increased. Hot days and nights have increased as well. strongest tropical cyclones in the North Atlantic. You hear them in the news. Although we cannot attribute each event to climate change, we know that their frequency is going to increase. And cold days and nights, so hot days and nights have increased, and cold days and nights have decreased. And very hot nights are also problematic, not just for human health, but also for the health of your products. So how do we attribute those changes to human action? Because some people just come to me and say, okay, you've convinced us, we trust you. Climate change is happening, but why are we human responsible for it? So to be able to do this attribution, we cannot have observations. We do not have an untouched planet and a touched planet. We just have one planet. So we rely on models, so on representations of the reality, the same models that you use, for example, for weather forecasts. Those kind of tools that represent or that assemble all the knowledge that we have about how our climate functions. And with this tool, we just play the tool once with just natural forcings. So that is solar activity, volcanic eruptions, etc. Everything that we know that is not human cause. And then we play this virtual planet again with human actions. And the largest human actions is our emissions of carbon dioxide, our emissions of greenhouse gas. And so what you have here is for the entire 20th century. In blue, it's when you play this planet without the human action. And you see that climate does not change. And in pink, it's when you play it with the increased greenhouse gas in the atmosphere. And there is no doubt when you play it with human action, and you know the physics behind. I mean, it's not just, there is some physics behind. We know that the climate is getting warmer. If we forget about human actions, then the climate is not changing, and the climate is also slightly supposed to cool down, because the maximum warming of our planet was what we call the Holocene period. It was about 6,000 years ago. And since that, we are supposed to enter a new ice age that we should reach in 60,000 years from now, because it's a 100,000-year cycle, the glacial, interglacial cycle. And we are drifting away from this natural trajectory of our climate. We are warming because of our actions. And if you play the same game on every continent here, you can see the North Atlantic, Europe, Asia, Africa, etc. And you look at the blue and the pink curve, and you see that almost everywhere they fall apart, and the blue is stable and the pink is increasing. And that is how we scientists confirm that what is happening is due to human actions. And it's not just one sector of human actions, because some farmers came to me, yes, you are always pointing to us. No, I'm not pointing to anyone. I'm as responsible as anyone else. It's our way we live, it's the way we live, it's our consumption. It's okay, we've been growing and expanding, and we had to feed some people, and we discovered new energy, new industry, and we made some progress, but there are some consequences, and one of the consequences is that one. So if we try to zoom a little bit into, so here France, because I've been working with French farmers as well. So you have at the top the change. So now the reference time is 1961-1990. It's not the same as the first curve I show you. I show you what you see is that what you look in France here and at the globe scale here, at the globe level here, it's the same, but every continent is warming a little bit more than what we have on average for the globe. So 1 degree Celsius of warming over the entire globe is about 1.5 degrees Celsius of warming over the continents, over land. Lands are warming faster than the entire planet, and in some regions it can be much more. So here is what, just in France, all those dots are changes in temperature between the beginning and the end of the 20th century. And the reddish color has the largest warming, and you see that at the scale of France, there is a southwest-northeast gradient with much warmer conditions in the southwest, reaching more than 1.5 degrees C, and milder warming in the northeast, about 1.1 degrees C. So even at the scale of one country, of course, the warming is not homogeneous. Sorry, and now if you want to zoom a little bit more also into some extreme variables, so here you will see at the top for Toulouse in red and for Paris in blue, the changes in the number of what we call summer days, days with temperatures warmer than 25 degrees C. And you see that in Toulouse, over the 20th century, this number has increased by about 6 days per decade, which is a lot. And in Paris, it's 4 days per decade. So those number of hot days are really increasing constantly. And at the bottom, it's the number of frost days that are also very important. And this number is decreasing due to warming. And you have Nancy, which is in the north part of France, and Paris. And in Nancy, we have lost 5 days per decade, and in Paris, 3 days per decade. So you can, so the role, our role, when I talked earlier about climate services, is really to come down to some finer meteorological variables that may be meaningful to the field where you work. So I introduced this earlier in saying climate change and climate variability is not the same. So here you have, let's say, a virtual evolution of temperature. You know that 1 month of July does not resemble another one, and that's what you see from one year to another one. So what you measure from one year to another one for the exact same dates or the exact same month is the variability. The atmosphere is a chaotic system, and as any dynamic chaotic system, there is instability, and this is what we are experiencing from one day to another, or from 1 month, 1 year to another one. But within this chaotic situation, you can have a trend. And this blue arrow is measuring the trend between this point and this time. So we are smoothing this change and see whether there is indeed an indication of growing. So this is climate change, and this is climate variability. And of course, if you compare both, even if you are in a warmer climate, you can experience years that are colder. Again, because we are in a dynamic system that is quite chaotic, that does not discard the fact that the climate is warming. So you just need to keep this in mind. So now, what is the imprint of climate change in the farming sectors? So I'm going to go through some evidences. This is showing you the changes in common wheat in France, so France as a whole, and then in Poitou-Charentes and in Aquitaine. And what you see, and what you probably know, is that the yields in France have started to stabilize around the years 1990, more or less. And since then, it has been experiencing some fluctuations. So since then, it has been the fluctuations are really related to climate, and part of the stabilization also have been shown to be attributed to climate change and climate warming. So there is also, even though there is improved genetic selections progress in farming, the climate can impose a limit in the possibilities that yields can still continue to grow. Those are the sowing dates for maize, for example. So you have sowing dates on the top left, you have yields on the bottom left, and grain humidity. I just heard earlier that there is a problem with grain humidity in terms of sorgho, and of course grain humidity is decreasing and has been decreasing since here 1970 in Poitou-Charentes, and this is because, of course, there is warmer conditions. Therefore, there is more evapotranspiration, and therefore desiccation and drying of the grain is easier in those conditions. So that's maybe a good part of climate change. And what you see here in 4 different locations in France is that the sowing dates, of course, are earlier and earlier, and this can also be attributed to climate change and to conditions that become favorable earlier in time during the season. If you switch to trees, to fruit trees, there is 2 contradictory effects. One, for example, if you look at this green curve here, which is apple trees in Niort, it's the end of dormancy. The fruit trees need a certain length of chilling period before bud burst occurs. And because the winters are warmer, this end of the dormancy period is later and later. And at the same time, the flowering period is earlier and earlier. So for the fruit trees, we see that their physiology and several signals of their physiology are coming closer to one another, and this may end up in some problematic functioning, physiological functioning of the fruit trees in many parts, at least, of Europe. So it's the same here. It's also changes in the flowering dates for pear Williams. And finally, a last example, which is grapevine. And of course, there are several things. Is that the harvest date is earlier and earlier. And I remember when I was a kid, harvest date was in September, and now it's in August. So it has taken more than a month in a lot of regions in the world. Then you also have the amount of sugar that has increased in almost all varieties of grapevine. And this, again, is because of increased evaporation, so it concentrates the sugar. And of course, it means that so here you have several varieties of grapevine, and you see the degrees that are increasing, and this is per decade, so it's 1 degree per decade, for example, for the Languedoc, which of course is changing completely the controlled appellation of most of the wines, and it's becoming a real problem. So people in wine have been aware of those problems of climate change quite early, a few decades ago. So now I'm going to jump into future changes. So how do we project ourselves in the future? We have several people working for that. So first we assume changes in the demography. So we project, so we work with demographers to try to see what will be the demography in the future. Then we work also on societal choices. So there is the business as usual scenario, but there are also some projections of how our choices are going to change. Is our choices in 50 years from now to become all vegetarian? That's one possibility, and that's one pathway that is explored. So you have several societal choices that are explored. Then there are technical progress is also explored to see whether we will be able to change and to switch from renewable energy, for example, or to have different sorts of way to move in the future. And when we put all this together, we end up with changes in how the land is used. So how much crops is going to be grown in the future, how much forest is going to be grown, and some changes in how the emissions of greenhouse gases and also of other pollutants are going to change in the future. And we use all this information and we put it in our virtual planet, which is the climate we are using. This is how we proceed. So we have a number of scenarios, and a number of scenarios are explored. So here, for example, I'm showing you results for 4 very different scenarios that are explored. The most extreme one is the red one, and the most reasonable one, or let's say environmental one, is the blue one. And you see that when you take one trajectory or another one, you end up at the end with very different levels of warming of the planet. In this one, we do not more or less go above where we are now. So we see that already it's impossible, because we are taking 0.2 degree per decade, and we are already at 1 degree Celsius. And here you can reach something like 4 to 5 degrees Celsius. And remember what I told you about last glacial inception, which was only 5 degrees Celsius colder. So these are different scenarios that we can explore. And the first time the IPCC, so the exercise was done by my community, was in the 1991, the first IPCC report that came out. And people said, wow, this extreme trajectory that you are describing is totally unbelievable. And since then, we've been tangenting this extreme curve all the time. We never went below the extreme curve that was produced in the 1990s. Despite all the government's will, despite everything, we have not changed. So we are really experiencing the worst trajectory. So if we continue, this is the path that we are going to face. And this is something that we need to keep in mind. What is absolutely certain, so this gives you the cumulative amount of CO2 in the atmosphere with the global temperature change. And in fact, those are perfectly correlated. So there is no doubt that our global warming comes from the greenhouse gas, essentially CO2 we are putting into the atmosphere. And the more CO2 we put into the atmosphere, the warmer we are going to get. There is no doubt about that. And of course, what only changes is the date when this level of warming is going to be changed, is going to be reached, because it depends on how much we emit each year. What is certain also, this is showing you trends in the coldest days, the number of cold days and the number of warm days, is that the warmer we are, the more warm days we are going to experience and the less cold days we are going to experience. And what is interesting is that, for example, for 1.5 degrees C warming, you double the temperature of the warmest day. So 1.5 degree warming means that you are going to add 3 degrees Celsius to the warmest day. So if the warmest day in your country is 42, with 1.5 you are going to be 43 degrees Celsius. Okay, if the warmest day is 25, your warmest day is going to be 28 in the future in a 1.5 degrees C. The coldest days, it's 4.5, so it's 3 times more. So if your coldest day today is 3.5 degrees Celsius, it's going to be 7 degrees Celsius in the future. So you are going to gain more in cold days than in warm days. But this again is perfectly, and you see all the colors here are the different types of socioeconomic scenarios, so levels of warming, and you see that there is a correlation with the warmer scenario is giving you the warmest increase in extreme temperature values, and the more reasonable scenario is giving you the least changes in extreme values. So again, there is really a good correlation between both. It's the same, here it's the same for extreme wet conditions. So this is the rainfall amounts for 5 consecutive rainy days. So if you have 5 days in a row where it's raining, the total amount of rainfall you are going to experience is going to be much bigger in a warmer world than today. And the rainfall amount in the rainiest day, so the most intense precipitation you are going to experience, is going to be more intense in a warmer world. And all those are really something that is very systematic, whatever the experiment you are carrying out. If you now zoom into Europe, so you have summer and winter, those are changes in temperature, and those are changes in extreme temperatures. Those are changes in mean seasonal temperature, and again, this is changes in the extreme. And what you see is that, again, generally, the change in the extreme is more important than the change in the mean seasonal value. And I think this is something that is more important than knowing that you have +1 or +1.5. It's really the changes in the extremes, because this is what matters for human behavior and for plant also activities. And this is the same for rainfall change. And you see that when you look at rainfall changes, in winter, most of the experiments are simulating increases in winter rainfall. So there is more water to be gained during the winter period, but with more intense values. But still, the areas around the Mediterranean is going to experience less rainfall even during wintertime, but maybe with some very extreme and intense precipitation during summertime. This is not completely robust. Really coming down to the climate change where you are at your locations is still something that is not easy to do for a climatologist, but we can provide tendencies. And this is just to play, it was published in one scientific French journal, and it's just to show you how maybe it's easier to think this way, how the climate will change in France, for example. So it is assumed that in Paris, we will experience the climate of Toulouse by the end of this century. And in Toulouse, they will experience the climate of Barcelona at the end of the climate century. So you can play a little bit with this, and I think it's also a useful game to try to see, because it shows also how the climate of southern countries are moving northward with climate change, and therefore, even if we don't know what to plant in the future, we can go and see in the countries in the south, what are they planting today, and can we imagine planting those, and this is what you do with the sorghum, planting this in our countries tomorrow. Okay, so now I come to the climate services. So what is a climate services? A climate service, from a climatologist's point of view, is all the information we can provide and service we can provide to estimate and qualify the past, present, and future climate where you are, to estimate the vulnerability of your economic activities, environment, and society to climate change, because there are some climate change is used for any purpose. Climate change is not first responsible of everything. All the inundation that we have been having in the south of France, of course, they are due to rainfall, but also to where people have built. Okay, so it's not climate change the only responsible, it's also the action people have taken to build and to put concrete material in areas where they should not have built, even without any climate change. So climate change is not the responsible of everything. So the idea is, when you are studying the vulnerability of a place or of a crop, is to really know what is the amount of vulnerability you have to climate. And if your vulnerability to climate is low, then maybe you do not need to invest in worrying about climate change, and maybe you need to invest about something else. So I think for me, climate services mean also not to put all our efforts where maybe it's not the most useful. And then it's also supply elements and supply information for you to be able to undertake either adaptation or mitigation measures. So that's what climate service is embedding, and it's something that you will hear about, I guess, over the next decade, because it's a new way for climatologists to look at what they produce and what they work on. So I found this paper came last year, and I found it was very interesting, and it's talking to everyone. It's about worrying about the Winter Olympic Games. And when you look at that map, that shows all the black diamonds are showing you the areas where Olympic Games have happened over the past century, more or less. And what you see is that the color on top of which it's put are the color of climate change for February, because it's generally when these games occur. And what you see is that, of course, they are all located where the climate change has been the biggest. Okay? So, and when you look at here from 1924 to 2014, and you look at average over all those cities, I mean, the change between 1924 and 60 was plus 4.4 degrees C, then up to 2000 plus 3 degrees C, and 2014 plus 7.8 degrees C since 1920. So obviously, it's becoming worrisome for Olympic climate games. So some climatologists, and it's the fun part of the climate service. It's really to be able to do this kind of things. So then they worked with people who are farming the snow, okay, and say, okay, what are the two basic indicators you need in order to think about whether you are going to be able to hold the climate games in the future. Not the climate games, the Olympic Games. Sorry. So they said, okay, well, we need to have at least a temperature that remains below 0 degrees Celsius. That makes sense. And we need to be able to keep at least 30 centimeters of snow, even if we need to farm the snow. So they just include also the fact that they can add additional snow and farm it. And so then they did this. So if you look at each city, you have a kind of 4 divided by 4. So when it's green, it's going to be climatically reliable. When it's red, it's not. When it's orange, it's really at risk. And on the left side, it's if really we manage to remain below 1.5 degrees C. And the right-hand side, so what it's called RCP 8.5, it's if we continue to emit as we do today. And what you see is that, first of all, whatever you do, you have a number here. Chamonix, for example, Grenoble, you have a number of already French cities that will, whatever happens, that will not be able to hold the Olympic Games anymore at the end of this century. Sochi here, whatever happens, it's not going to be able to hold. And you have some, of course, some cities in the north that will be able to hold those Olympic Games. So I'm not telling you that that's exactly the truth. I mean, it needs to be enhanced with all the experiments to make sure about the robustness, but that's what a climate service can be, is really to try to think ahead in the future and think about what may happen. So what we've started to do, and that will be my final example, we worked a little bit with the case of corn, and we looked at how two varieties will evolve in the future in Ile-de-France and in Midi-Pyrénées, in those two areas in France, and those are the two varieties, so an early variety and a long variety, to see how they will change. So what we looked at first is whether the sowing dates are going to change, because of course the sowing dates, you based your sowing dates on the knowledge of climate and how climate have changed over the past, let's say, 10 years. So what you see is that for the two varieties in Midi-Pyrénées, the dates are still going to move forward, so it are going to keep advancing in time in the season. It's the same for the Ile-de-France, although it's not that much an advance in time, because we still have cold conditions and frost risks if we sow too early. What is interesting, for example, is that here the late variety is not yet sown in Ile-de-France because it does not finish its cycle. But after 2060 or 2070, our knowledge of what will happen in the climate of France says that we will be able to sow those kind of varieties at that time in this region of France. So that's also a knowledge that we can gain because it will completely finish its cycle. What does not change a lot, and probably because there are some also conditions of drought, etc., is that the length between emergence and maturity does not seem to change much from this experiment and for the two varieties, at least in Midi-Pyrénées, but in Ile-de-France, we are going to shorten this time period between those two specific time periods of the phenological cycle of corn. So then what we looked at is that we looked at the meteorological stress that the plant would experience in the future from between specific time periods. And here, for example, we look at the frequency that the temperature will go above 35 degrees C during grain filling period. And this is what we had in the recent past, and this dark gray is what we are going to experience by the end of this century. And you see here Midi-Pyrénées early late variety, Île-de-France early late variety. What you see at each time is that you are, of course, increasing the risk that you are going to have days with this value larger than 35 degrees C, which is problematic for grain filling at that time period for those two varieties. And of course, in Midi-Pyrénées, you see that we can have more than 10% of the days for some specific spot or scenarios, more than 10% of the days during that time period will be above 35 degrees C. Another indicator, for example, during that same time period is the frequency of a day with a soil water that is too low for the plant to really correctly function. And here again, you see that the time spent with a low soil water is going to increase dramatically in Midi-Pyrénées, but also in Île-de-France, with more than, in Midi-Pyrénées here, for example, more than 50% of the time will be with those varieties being below what they can really pump in terms of water, which means, of course, that irrigation will be needed. Okay? So that's the kind of things that we can do. So in terms of concluding, and before we go to the question and answer, so in terms of climate change, so we've already reached +1 degree C since 1850. Global warming is correlated to our emissions of greenhouse gases, essentially CO2. The hot extremes, the extreme rainfall events increase with warming, so it will continue to increase. In terms of agriculture, the imprint of climate change is already visible in many sectors. I have shown you crops, grapes, fruit trees, but there are others. What is interesting is that we can build tools to anticipate what will happen, depending on what we want to look at. And this is what we call climate services. And for the example of corn, what I've shown you is that the sowing dates will be earlier and earlier with climate warming. It will be possible to grow late season variety in the northern part of France, but extreme or lethal temperatures may be more frequent during the grain filling period, which is problematic. And the number of days with insufficient soil water during grain filling may double before the end of this century, which is also probably problematic because it will mean using more water, and we don't know whether this water will be available because the season of the water availability is changing also with climate change. And with this, I thank you.
Merci beaucoup pour cette présentation. Yeah, English. I need to stick to English. Sorry.
Up to you.
Okay, so maybe I will ask the first question. It seems that all these climate change impacts that you explained are very good for sorghum to be grown in Europe.
That's what I was told. And I remember that one of you this morning said that we need to maybe have projections of the areas where sorghum could be sown. And this, I mean, working on those climate envelopes with you and see where those climate envelopes are going to change, to have the climate niches of the varieties you have, is something that can be done. It would be very interesting.
Maybe something that would be really helpful would be to have this map, the same map that you had for France with the changed names of cities for the whole Europe, and then we could maybe project where sorghum could be the most appropriate. We have one question.
I would like to congratulate you for your presentation. I appreciate it so much. So I get in mind that this is a big difference. But you know, I think that change is not the same as variability, right? Yeah. Variability is not the same as change, so I get in mind that this is very important for me as a new concept. So the question is, so the variability has been increasing over the last years. This is my first question. And the second question is, we are hearing from the farmers so many times, in hindsight, I would have done that differently. So variability for farmers is a big issue to deal with.
Yeah.
So my question is, can you anticipate variability, over 1 year, 2 years, in order to change your way of producing? So this is my question. Thank you.
Yeah. So it's a very tricky question, because climate variability is increasing with global warming. So that's for sure. So the extreme from 1 year to another can really increase with climate change. That's something we are sure about. About anticipating from 1 year to another one, or from one season to another one, is very difficult, because it's like weather forecasting. We will never be able to do better than what we do today over the next 5 days, because this is where we hit the chaotic nature of the atmosphere. And we are in this short-term predictability. It's much easier for a climatologist to have a long-term predictability than a short-term predictability, because the short-term predictability depends on all the initial conditions that we feed our model with. And all these initial conditions would mean being able to have the exact amount of soil water content everywhere in Europe at instant T when we start our projections for the next 3 months. Same thing for temperature, etc. And this is impossible. When we go to long-term projections, we are more constrained by what we call boundary conditions, the amount of CO2 in the atmosphere, the state of the ocean, etc. But so it's the most challenging thing, and we know it's important, and we work hard on this, but it's the most challenging for a climatologist. And yes, progress is going to be made, but I don't know when, and that's why I think we need to work on the trends, and in exploring, we come more into statistics. For example, we have about 44 models around the world, climate models running, doing hundreds of scenarios. So we have an enormous sample to explore, from which we can say there is 90% risks that this will happen, and 50% risk that this will happen. So we can scale a little bit, and we can try to come to what is the most certain, and start to see what we can do knowing the most certain, and wait for the less certain to become more certain. So I don't know whether it's clear, but it's really very, very complicated. But I really know that it's what you need. We all know, but we are doing our best.
Another question? Sorry.
Yes, thank you very much. It was a very, very good presentation. Very intriguing, but at the same time a little bit worrying when you look at this, at least from the farming point of view. There is a lot of things going on. And I agree with the previous question as well. I mean, we would need these kind of a more short-term, how would I say, modeling that would enhance us and make us easier to build in some new risk management tools, etc., etc. But my question is that we as the farming sector, farmers usually say, count us in, we are part of the solution. What do you, as now from your point of view, what do you suggest that we should do, and which things would be the most effective? When you look just at Europe, you don't need to look at a bigger area, but look at Europe.
What, I'm not sure I understand. I mean, is your question about what you grow or about farming in general?
No, how will we be part of the solution to make sure that we will stay below 2 or 3 degrees? So how do we come in? Then we can see which crops. I think sorghum will be among the crops, I'm sure of it. But what would be the most effective way from the farming point of view to be part of the mitigation or the solution, or even stop the climate warming?
Okay, so my questions will be, my answer will be in two different parts. First, of course, you can play a big game because there are many solutions to store carbon by farming. It means changing the way we farm, of course. It's not cleaning completely our soils and not returning our soils, etc., and not doing some plowing. So that's it. But at the same time, you need to know that all land together. So if you include bioenergy, if you include what you can do in farms, and if you include afforestation, we are not going to be able to do more than 30% of the storage, okay? The 70% remain our way of living, the industries, and the transports. So all the expectations are not on the shoulders of farmers, okay? Even though we know that farmers can do a lot and can store carbon. So of course we know that today, I mean, the way farming has been done after the Second World War is not storing carbon, it's releasing carbon, and you all know that. And so there is progress to be made with that. You talked about bioenergy. I think it's a great thing to think about what we can do in terms of bioenergy and improving that. And then I think there is some also progress to be made in terms of irrigation, not because it's changing climate, it's because you are going to have less water. So of course, so I would say that those are the three main points that you need to work on, but again, just the farming part is something like 10 to 15% of the potentialities, and land altogether it's 30%. So if you all do the best you can, and foresters do the best they can, but the industrials do not change, it's not going to work. So it's really everyone, okay, not just you, but I think those are what I would recommend. It's really try to store carbon, limit irrigation, and try to work towards bioenergy.
Next question.
Yes, Van Wissen, thank you for your presentation. But then we are agriculturists, and there are some things I don't understand, for example. I don't understand your explanation or your interpretation of an early varieties and late varieties.
Yeah, that's
in terminology, it is early, is a short term.
Yeah, short term. Yeah, I'm sorry, but maybe I translated.
But nobody going too late to seed maize in June. What do you want to explain us there?
It's the one that don't need that much a long time period to grow, and the one that you can expand on a much longer time period.
Exactly. You plant them all at the same time. So doesn't work. Your big explanation there. Sorry to say.
It's probably in our literature you often find early and late, or short and long. So sorry for that bad
very
translation.
Very unprofessional. Sorry to say. Very unprofessional.
One of the advantages of sorghum, of course, is that it's a C4 crop.
Yeah.
So you stack C more efficiently than you would do with the traditional crops.
That's
like
right.
Wheat or barley or oats. So as such, there is your little percentage of extra leverage from sorghum.
Yeah.
And that's why I think sorghum needs to be given attention as well.
Yeah, that's a good point, yeah.
Another comment or question?
Yeah,
I
have a question about collaboration, or did you or will you plan, did you plan to collaborate with entomologists and plant pathologists to model or to predict the impact of climate change on pest and disease dynamics?
On?
Pest and disease dynamics.
Yeah, that's something that we are being asked more and more. You are right. It's really the fact that there is not just the physiology of the plant, but there is the climate niche of pests and disease is now overlapping and is going much quicker in terms of changing than the adaptation of the physiology. So it has started. There is not that many studies yet available, but it's growing considerably, and yes, I think it's really taken quite seriously now. You're right. Yeah, it's a good point.
Who else has a question?
I'm from Russia, and I want to say one of the biggest direction in for you can see in the world, and FAO writing about this always. It's a no-till technology. It stop carbon emission. And yesterday was a very nice presentation, lady from Australia, and she told about most modern technology. It's direct seeding with controlled traffic farming. This is what we have to discuss, and nobody anymore in Europe did not tell about. All farmers told only about they are plowing, and they way no out of a situation with climate change. And I think sorghum, why we're here from Russia, because we try to develop direct seeding in most difficult climate condition in Volga region, and learning about sorghum, because it's a very good crop for direct seeding in crop rotation. But it's pity that nobody discussing about this important challenges to stop sequestration of CO2, to keep carbon in the soil. Thank you.
Thank you. We have another one in the back.
Yes. In terms of farming point of view, do you think some areas will be less affected by this climate change? Maybe for the next 30 years, maybe if I talk about the Black Sea or South America or...
Yeah, so I mean, what your question is, can we identify those areas?
Yes, and will there be some areas less affected by this climate change?
Yes, of course. I mean, it's not homogeneous. Okay, it's completely not homogeneous. So yes, of course, there are areas that will be less affected, but I think this needs. We then need to. I mean, if you just look at. I mean, if you remember the map I showed about for the Olympic Games, you see that the northern, for example, the northern latitudes are warming much faster than the temperate latitudes. And the northern latitudes are becoming more wet, and the Mediterranean regions is coming more dry. So yes, there are some regional contrasts, and it is possible to, when we started with the climate envelopes, it is possible probably to calculate the areas that are going in the next decades to suffer less from climate change, and of course it's something that we can try and produce. That's it's completely inhomogeneous.
One more question. That's it. Everything is clear.
Firstly, I would like to say thank you for this presentation. It was really interesting, although it was a little bit frightening. But I have a question, which is more questions we got in a viewpoint of the farmers, but I have a question in a viewpoint of the customers. And it is not my opinion. My opinion doesn't count here. But there is a propaganda in the media, in the internet, that one customer can do, that go vegetarian or go vegan, to decrease the climate change. And what is your opinion? It could be a solution. Of course, I know that there is animal breeders here, but it could be a solution to go vegan and eat sorghum, for example, or other plants either, to decrease this frightening process. Thank you.
You just have 1 minute.
Sorry?
You just have 1 minute.
No, that's a very good point. And yes, there are some studies that are showing this now. You will have another special report from IPCC that is going to come out in August 2019. So in a little bit less than a year from now, that addresses those questions of food security and climate. And yes, indeed, reducing the amount of meat in our consumption definitely reduces the emissions of greenhouse gases, through not just because of our consumption, but because it reduces the number of animals, it reduces a number of transformation, it reduces a lot of things, and it also reduces the amount of land use that we need to feed those animals. So yes, the papers, or what is the share of it in the total, I cannot tell you now. Maybe this will be estimated within the next year, but there are some papers that indeed point that one of the solutions is not to solve everything. Again, like if you are doing good practices, it's not going to be 100% of the solution, but it's part of the solution, yes. To reduce, at least. I think it's to reduce the amount of meat in our daily food. That's for sure, yeah.
Okay, we need to thank you now because time is flying. Thank you very much again.